Hello, this is AJ Eichenberg.
This is Sawyer Webb.
This is Lab 10 of OPTI380 laser diodes and LEDs.
Our TA was Senor Vets.
So for part A, we had a bunch of photos that we had to output. So these are our LED emission at the different colors, red, green, and blue. We calculated our LED emission area to be around 300 pixels or 0.765 millimeters for all three. Our measured cavity length was 540 pixels or 1.3 millimeters. And then this is our laser at a very low drive current.
So for this part, we put 3 LEDs, laser diodes, and a laser cavity under here. We did separate measurements. For the LEDs, we measured the area of the LEDs. For the cavity, we did the size of the cavity. And the laser diode was the structure of it. All under the microscope from a camera. That just gives us a
And for part B, this is our LED emission spectrum, and we're going to play a video explaining how we did it all.
In this lab, we measured the spectra of the LED and the laser. For the LED, we hooked up our LED here to a detector, which is hooked up to our emission spectrometer, and then we measured the threshold peaks. So, the upper, lower, and middle threshold. And then we did the same thing with our laser over here. We put it in a hole, and then we measured the upper, lower, and medium peaks.
All right, and then these are our emission spectrum for the laser diode. And we calculated our delta V, or mode spacing, to be 72 picometers.
So for part C, we took an LED and an LD, and we measured power versus angle. For the LED, we did from negative 90 degrees to 90 degrees. And for the laser diode, we did from negative 50 degrees to 50 degrees. And we also took a manual polarizer, and we did the highest output and the lowest output that we could find for both those sources. And here's the ratio for all 4 of those data.
So for part D, we used the LED and the laser to measure the power output of each against the drive current. So for the LED, we use the drive current here to change it and steps of 4 milliamps. And then we measure the output in microwatts. And then for the laser diode, we measure 4 milliamps again, but we use nanowatts. And to block outside noise, we use a cloth, put it over the LED and laser to get exactly the right data for the nanometers.